Alright, welcome everyone to my YouTube channel. So in this video we're going to look at the derivative of trigonometric functions. Alright, so there are basic trig functions, sine, cosine, tan, and these are the inverses. Cot is the inverse of tangent, cosec is the inverse of sine, while sec is the inverse of cos. Alright, now previously I've done a video on the derivative of sine as cosine x and how it was gotten. We used the definition of first principle, and I also said we should try that, of course, using the same process. You can find this video in the description below. The link is there and other related videos. Now we're going to look at these other four, and to be able to find this, we're going to apply the concept of quotient rule. Now, meanwhile, if you have not subscribed to our YouTube channel, please kindly do that. We appreciate. Thank you. All right, so beginning with the first one, which is tan. So in this case, our y is going to be equal to the tan of x. All right, so to apply quotient rule, we know that by trigonometry, tan is actually equal to the sine of x all over the cos of x. So that is to say that our sine is the u and our v is your cos. So by definition, our formula dy dx is equal to v du, where du means du dx minus u dv all over v squared. All right, so if we now substitute, we are going to have our v is cos x multiplied by du, derivative of sine x, which is also cos x from this table here, and then minus our u now multiplied by the derivative of cos, which is minus sine x, all over the square of v, which is cos squared x. All right, so at this point now, we will need to multiply out what we have, and that's going to give us cos squared x minus sine x times minus sine x is plus sine squared x all over cos squared x. And now, we recall that there is a relation in trigonometry that tells us that the sum of the square of x, cos squared x plus sine squared x, is actually equal to 1. And this is all over the square of cos x. And then I already said here that the inverse of cos is sine. And so that means the inverse of cos squared is actually the inverse of cos is sec. So the inverse of cos squared is going to be sec squared x. And that's how we got the derivative of tan x to be equal to sec squared x. So we go to look at the second derivative here. All right, so for the second one, our y is cotx, and so the cotx we know is the same thing as the inverse of tan, and we said here that tan is sine x over cos x. Therefore, cotx will be cos x all over sine x. Okay, so in this case now, this is our u and this is our v. So the formula is already stated here, and we're going to just use it. So we have dy dx is now going to be equal to our v is sine x multiplied by du, which is minus sine x, minus, now our u is cos x, multiplied by the derivative of v, which is cos x. All right, so, and this is all over, we have all over the square of the denominator, which is sine squared x. Okay, so now continuing here, we are going to have that our dy dx is simply equal to, if you multiply this, you're going to get minus sine squared x, and then this is going to give you minus cos squared x, okay, all over sine squared x. So we have minus sine squared x minus cos squared x all over sine squared x. Now here, if we factorize minus 1 from here, we are going to have minus 1 into sine squared x plus cos squared x all over sine squared x. All right, now, but we, like I said earlier on, sine squared x plus cos squared x is equal to 1. So this is going to give us 1 minus 1 all over sine squared x. Now, but we know that the inverse of sine is cosec. Therefore, the inverse of sine squared is going to be minus cosec squared x. All right, and that's the solution, and that is how this was gotten as the derivative of cotx. Okay, so now we are going to look at the next one. The next one is the derivative of cosec. So, and that's the c part. So our y now is cosec squared, cosec x, sorry. So if our y is that, and this is equal to the inverse of sine, so that means that our dy dx is going to be equal to, remember that this is the same thing as our u all over v. Okay, so here our u is 1 and our v is sine x. So this is going to give us v, which is sine x, multiplied by the derivative of u, which is 0, minus u, which is 1. Derivative of sine x is cos x, sorry, and that is all over the square of the denominator, which is sine squared x. All right, so from here we are going to have that this is going to be equal to, of course, this is going to give us 0, and this is going to be minus cos x all over sine squared x. All right, now, but this is the same thing as we can break this thing down here to give us 1 all over, let's say, minus 1 all over sine x multiplied by cos x all over sine x. Of course, you know, if you multiply this out, you will get back this. Minus 1 times cos x will give us this. Sine x times sine x will give us sine x squared. And so our final answer for dy dx is equal to, if you take this, the inverse of sine, we said is cosec. So you have minus cosec x, then multiply by this one. You know that this is the inverse of sine over cos, which is the inverse of tan, and so that's going to give you cot x. Okay, so, and that's the solution for that. And if you check what we have there, you will see we have minus cot x multiplied by cosec x, and that's exactly what we got. All right, so, and finally, the last one we want to look at is how they got the derivative for secx, which is the inverse of cos. Okay, so here now our u is 1, our v is what? Is cos x. And so if you using the formula that we already stated, that means dy dx is equal to v, remember v du, our v is cos x, multiply by du, our u is 1. If you take the derivative, you have 0, minus u, which is 1, multiply by derivative of cos, which is minus sine x, all over the square of the denominator, which is v squared. Okay, and so from here, you are going to have that if this multiplies, you have 0, and then this is going to give us minus times this is plus sine x all over cos squared x. And of course, like I did here, we can break this into 2, and that's going to give us 1 all over cos x multiplied by sine x all over cos x. Of course, if you multiply this out, you get back this. And so finally, our dy dx is equal to the inverse of cos is sec, and then sine x all over cos x is equal to tan x. All right. Okay. If you check here, you will also see that we have tan x, sec x. Of course, we know that multiplication is commutative. All right, so that's how to find the derivative of the trig functions that we have, the basic trig functions and their inverses. Okay, so in subsequent video, we're going to see examples involving these the derivatives of these trig functions. All right, And this is where we'll end it for this video. Kindly subscribe to our YouTube channel. Like I earlier said, comment, like, and share our YouTube videos. Bye.